Hi, I'm Jochen from company Moog. We are headquartered located in East Aurora, Buffalo, New York, and I'm coming originally from Unna in Germany. And Moog is very busy in the wind industry. That's the reason we are here on the show that week. And we have different solutions for the wind industry, for the turbine manufacturers and for the operators as well. We are going to present here on that show. It's a very important show for us. And if we go around a bit over our booth, and I will explain you a little bit more what we are showing here. And we have a wall with a picture on it which explains very well what Moog does in wind. So let's go to that wall and I'll show it to you. On that wall over here you can see some devices in red, in blue and in green, and you can see the turbine nacelle over there and the blades, the three blades. And if we start with the device in blue, that is a wind turbine slip ring. So as you know, the wind turbine slip ring is a very important product in the wind turbine because it ensures that all the power the pitch control system needs and all the signals which are sent from the turbine main controller to the pitch control system is transmitted by the slip ring into the rotating hub. And now you could ask, how does such a slip ring look? So if you go over here and you look at that device here, that is a wind turbine slip ring we are using in that special device we are using for replacement in the aftermarket for one of the big wind turbine manufacturers for 1.5 megawatt turbine. And such slip rings, they have a very high reliability, they are maintenance free and they survive for more than 100 million revolution. 100 million revolution, that is a very good part of the wind turbine life, probably the whole life. And if we have a look to the green devices over there, that are the green devices in the blade, you can see it. Over here we have some green patterns and there are sensors in, that are fiber optic sensors. And now what we are doing with the fiber optic sensors? The sensors are implemented in the blades and we are able to measure the blade loads. We are able to measure the blade loads and we are able to measure the ice on the blade. So we are doing ice detection. We are able to measure damages as well, so that's the blade damage detection. And we are able to reduce loads by measuring those loads, or the turbine manufacturer, he can run his turbine with an individual pitch control, but to do that he needs the detection of the blade loads. And that is all the hardware we are delivering here, the solution. And if we now have a look on the wall again, on the red devices, on the red parts, that is the pitch control system itself. So what does a pitch control system do? The pitch control system pitch the blade angle of the wind turbine. That means at a situation where you have no wind, the blades are fully in the wind and the turbine is waiting for the wind. And now the wind speeds up and nothing happens at the turbine, the rotor starts to return, and up to the nominal, to the rated wind speed, the blades are in their position full in the wind. Then, if we are exceeding the rated wind speed, the rotor would accelerate faster, it would run faster, and it would go in an overspeed if we wouldn't pitch the blades back. That means out of the wind. So, the pitch control system is used to keep the wind turbine rotor speed at a constant revolution speed. So, constant round per minute. The second task of the pitch control system is to stop the turbine. That means pitching back the angle out of the wind means that the surface where the wind hits the turbine blades gets smaller and smaller because we are turning the blades out of the wind. And while we are doing this and the rotor is still turning, the blade surface is pressing on the air. And so we have an aerodynamic brake. That means the pitch control system is it ensures to have an aerodynamic brake, and that is the only safety system, the only safety brake a wind turbine has, and that makes it such important. So we are doing that stuff for a lot of years, and for the electromechanical pitch control solutions we are the world wind pitch system market leader, and our pitch control systems and our components are in more than 15,000 turbines running worldwide. And additionally, of course, some turbines they do have a hydraulic pitch control solution, and in that area we are very successful as well. There we are not delivering complete pitch control systems, but we are delivering the main hydraulic components you need to do so, and that are the hydraulic pumps, the radial piston pumps, and then as well that are the hydraulic valves. And now you will see that now the story ends where it began for Moog, that is the hydraulic servo valve. Moog was the inventor in 1952 of the hydraulic servo valve, and that is where we have our core experience in the hydraulics, and we are running a huge business also in aircraft, also in space and defense, beside our normal other industrial areas like medical components and industrial applications. So we started with the components, we end now with the component, and that is the very first component we ever had, the hydraulic valve. Thank you very much for your attention.